Hi, in this video we'll learn to integrate an exponential function. Okay, so our two rules are the integral of e to the x dx is e to the x, and that makes sense because our derivative of e to the x is just e to the x. Okay. And similarly, if we have the integral of e to the u du, then that's going to be equal to e to the u. So I have a couple of examples here. The bottom line is you need to have the derivative of what is in your exponent in order to integrate this. So first thing I'm going to do is look at my exponent, and here it's minus x to the fourth. And if I think of what the derivative is of that, I know it's minus 4x cubed, so I need to have that. And look, right here in parentheses I can group that with the dx, and that is my derivative. So keeping in mind that the integral of e to the u is just e to the u, since I have the derivative, the integral of e to the minus x to the fourth is just simply going to be e to minus x4, and then add my constant. Let's do another example. Again, down here, if I let u be e to the x plus 1, then my du is just going to simply be e to the x. Notice that I have another e to the x here. If I take that along with dx, I have the derivative. So now I can just apply this rule here, that the integral of e to the u is du. But notice I have, if I let this be u, this is u squared. And what do we know about the integral of u squared? It's going to be u cubed over 3. So this becomes this becomes u cubed, so it's e to the x plus 1 cubed divided by 3. Then add your constant. All right, so in essence what we've integrated in this case is u squared, which we know to be u cubed. And that should be du over 3. Two more examples. All right. In this example, I have e to the 1 over the x squared. So if I take my u, okay, to be 1 over x squared, I know that my du has to be negative 2 over x cubed. Notice that I have over x cubed part, I don't have the negative 2. So I want to have a negative 2 in the x cubed dx. That's going to be my derivative. Because I added the negative 2, or I put in the negative 2, I have to put a negative 1/2 out front. The integral e 1 over x squared. I'm sorry, that's the e, that's an exponent. So here's my derivative, okay? And now I'm just going to integrate 1 over e to the 1 over x squared, which is simply going to be e 1 over x squared. I have the minus 1/2 that was out front, e to the 1 over x squared, and then I need to add my constant. And again, this just follows because e to the u is just e to the u, provided you have the derivative of u. And finally, let's do one more example. In this example, I'm going to let my u be my denominator over here, okay, which is e to the x plus e to the minus x, okay? And now I know my derivative is going to be e to the x minus e to the minus x. Okay, remember our derivative of e to the x is just e to the x, and then I have to take the derivative of the exponent. In this case, it'd be a negative 1, so I put that out front. All right, now do I have that derivative? Well, yes, notice here I do. So this becomes the integral of 1 over my u du, okay? And now what was, if I take this part with the dx, that's my derivative, okay? So do you remember what the integral of 1 over u is? Well, that's where our natural log comes into play. So this is going to become the natural log of u plus c, but in our case, the u is e to the x plus e to the minus x. So this is going to be equal to the natural log e to the x plus e to the minus x all plus c. All right, and now I did make one little error. These need to be absolute values here. All right, so that's 4 examples of how we can integrate exponential functions. Again, the bottom line is the integral of e to the x is just e to the x, provided you have the derivative of the exponent.